Assalamu alaikum. This is the fourth and last video for solving Edexcel International AS or A-Level JAN 19 M1 paper. Question 7. Two particles A and B have masses m and 3m respectively. The particles are attached to the ends of a light and extensible string. Particle A is held at rest on a rough horizontal table. Okay, we have a rough surface. The coefficient of friction between the particle A and the table is 1/5. The string lies along the table and passes over a small smooth light pulley that is fixed at the edge of the table. Particle B is at rest on a rough plane that is inclined to the horizontal at an angle alpha, where tan alpha, very good, 4/3, we have alpha already, as shown in figure. The coefficient of friction between particle B and the inclined plane is 1/3, okay? The string lies in the vertical plane that contains the pulley and the line of greatest slope of the inclined plane. The system is released from rest with the string taut at B, and B slides down the inclined plane. B will slide down, and of course A will move to the left. Okay, given that A doesn't reach the pulley. Okay, A, find the tension in the string. Wow, 11 marks. Put in your mind that you should get all these marks. Okay, it's very easy. It's so easy. You will study each particle separately. We have connected particle problem here. Okay, starting from A, we can do the following. The weight of the particle we have here mg, and of course this is the reaction for particle A. We have tension in this direction, and we have here 1/5 Ra, mu R. Okay, mu R here 1/5 Ra. So for particle A in vertical direction, we have an equilibrium. For particle A, this is particle A. For A, we have in the vertical direction R A above equal mg below. Okay. The second equation will be in the horizontal direction, which we have an acceleration A here. So we can write T minus 1/5 Ra, T minus 1/5 Ra, but wait, Ra is the same as mg. So we can write here mg, right? Equals ma. This is the first equation here. And now we will go to the particle B, okay? For particle B, we can do the following. The weight of the particle is 3mg, and of course we have here the reaction of particle B, and this angle also is alpha, and we resolve 3mg to be 3mg cosine alpha, and here we have 3mg sine alpha. So we can make something like this, already resolved force. And then we have here the tension T, and also we have the friction force, which is 1/3 Rb, which is mu R. Okay. In this direction, which is normal to the line of greatest slope, we have equilibrium Rb equal 3mg cosine alpha. What about cosine alpha and sine alpha? We have here the following. We have here this interesting triangle alpha, and tan alpha equals 4/3, right? This is 4, this is 3, and of course this is 5. And then we can get cosine alpha to be 3/5, and cosine alpha will be 4/5. Okay, so we can write here Rb equal 3mg cosine alpha. Rb equal 3mg cosine alpha. But cosine alpha equals what? Equal 3/5. So we can write it as 3/5 times 3, 9/5 mg. So Rb equals 9/5 mg. Okay. In this direction, which is parallel to the line of greatest slope, the particle B will move down with acceleration A. So we will apply the equation of motion here, right? 3mg sine alpha, 3mg sine alpha minus the tension minus the friction, which is 1/3 Rb. I can replace Rb with what? With 9/5 mg. Okay, equals what? Equals the mass of the particle times the acceleration. which is 3ma. This is the second equation, and now we will go to the algebra part of the problem. We want to solve to get t, okay? We will find that this part is ma as the right hand side of this equation, ma also. So we can substitute 1 and 2 very easily, okay? 1 and 2. Okay, 3 mg sine alpha. Sine alpha, as we said before, is 4 over 5. So we can multiply directly. 3 times 4 will be 12 over 5 mg minus t. Here we can make simplifying. 9 divided by 3 will be 3 minus 3 over 5 mg equals 3, and then I will open bracket to put t minus 1/5 mg. Or we can expand 3 directly on the bracket to be 3t minus 3 over 5 mg. Oh, we are lucky because negative 3 over 5 mg will go to the left hand side by positive sign, and it will be cancelled with this, and then we have only here 12 over 5 mg, and we will move negative t to the right hand side to be 4 t. So by dividing by 4 we can get t to be 3 over 5 mg, or approximately equal 5.88 m. Okay, very good. Part B, state where in your working you have used the fact that the string is modeled as being light. Okay, of course you know that since the string is light, we can say that its mass or weight, whatever, not considered, okay? Or we can write, one of them is sufficient, okay? We can write the tension force will be constant. The tension will be constant for all what? For all points of the string. For all points of the string. Or other equivalent, okay? Part C now. For the pulley, we can draw the following. This is the pulley, and we have here the tension T, and here the same tension T, so that we can make a very interesting thing. We want to get the resultant on the pulley, okay? Okay, this angle is alpha, as you know, and since we have equal forces, equal magnitude of forces, the resultant should bisect this angle, okay? We have here 180 minus alpha divided by 2, okay? 180 minus alpha divided by 2, and the same is here also. 180 minus alpha divided by 2. And then we will make a very interesting thing. We will resolve t in this direction and in this direction. And also this t will be resolved in this direction and in this direction. Though the components which are here will cancel each other, okay? And we will add t cosine, okay? To cosine what? 180 minus alpha divided by 2. 180 minus alpha all divided by 2. And we have here the same thing for the other tension, so it will be 2. So the resultant of the force acting on the tension should be 2t cosine 180 minus alpha all divided by 2, which can be calculated easily to be what? To be 5.26 m. To 3 significant figures. Okay, thank you and bye bye.